Welcome to Giants, where we study with a cup of tea because anything is more fun when you have something to drink. So go and grab your drinks while I go and grab the science. In this video, we will be proving that limit h tends to 0 sin h is equal to h. Now, it's a commonly known identity, but why is it true? Do you know why? Let's find out. So, let's assume that this is a unit circle, just to make life easier, and this is its radius, which will be equal to 1 because we said it's a unit circle. Now, let's just make a triangle right here using this tangent. So, this is 90 degrees. Now, this length, as we know, using tan theta is equal to AB divided by BC, assuming that this angle is theta. So we can say that since BC is equal to 1, this is the same as AB. Great. So let's just write that this side is tan theta. What about the area of this triangle? It should be half AB into BC. So we can just write that BC is equal to 1. So this is AB divided by half, which divided by 2, which is the same as tan theta by 2. So that's done. Now we can just make think about this sector. We know that the area of a sector is theta by 2 pi, which is the whole circle, multiplied by pi into r square. So we can cancel out the pi and we get theta by 2 into r square. Now r is equal to 1 right here. So we can say that this is the same as theta by 2. Now let's talk about this triangle. This is perpendicular and this point D and this E. So for triangle CDE, we know that this length is now 1 because it's the radius, not this one. So we can say that sine theta DE divided by CD is equal to DE because CD is 1. So using that, we can say that the area is half DE into CE. So we can say sine theta by 2. But what about CE? CE isn't 1 anymore. Okay, so let's think about cos theta. That would be CE divided by DC. But DC is 1. So we can say that it's equal to CE. So let's multiply this by cos theta. Great. So now we can simply see that triangle ABC is the largest in area Sector is slightly smaller, and then we have this smaller triangle, which is the smallest one of these. So let's just write that down. So we get tan theta by 2 is greater than or equal to theta by 2, which is greater than or equal to sine theta cos theta divided by 2. Now all of these halves can be just removed. Now we get tan theta, theta, and sine theta cos theta. Now we can divide by sine theta, which gives us 1 by cos theta, because tan theta is equal to sine theta by cos theta. Right, so we get this. So now, inserting the limit theta gets closer to 0, so we can simply remove the limit on this side and this side, because we want to know what the value of the middle term is. Right, so now we can put the value of theta as 0 in this equation, and then in this part. So we get 1 by 1 is greater than equal to theta upon sine theta, which is greater than equal to 1. So now tell me of a number which is less than 1 or greater than 1. It's 1. So we can say theta by sine theta is equal to 1. Of course, the limit here would stay the same. Theta goes to 0. So we can also just simply rephrase it as such or as this, and hence proved. That's all. There's nothing else. This is the simple proof.